My name is Neil Stepanov. I'm a developer and researcher at the ITMO University. Today we're going to talk about the benchmarking of SaaS solutions. I deal with static and dynamic analysis of software starting from 2015. I was involved with the Kotlin compiler, and I found several dozens of bugs, and I successfully received my PhD. Here is the plan. The problems, SaaS benchmarking, why would we choose this, what is our benchmark capable of, and experimental runs. The existing benchmarks are not quite fit for the SaaS quality performance analysis. Then we present our tool and the results of preliminary experiments. This is a work in progress initiative. That means that all artifacts, all methods are not finalized yet. I'm not going to tell you for yet another time how things are going, how vulnerabilities in our starships may lead to catastrophic consequences. Rather, I would like to showcase an image. It illustrates a database of NVD, National Vulnerability Database. This lists the number of documented and fixed vulnerabilities over the last few years. The problem is still relevant. It is still serious. If it were not serious, we wouldn't be here today. Some years ago, this problem was not yet the focus of attention. It's either apps were not tested for vulnerabilities at all, or they performed some manual testing minimally, which was not sufficient. Then we proceed with methods of automatic vulnerability detection, which increases the chance of identifying critical vulnerabilities in your applications. Today, there are a multitude of various methods. This slide lists the key ones, and today we're going to talk about SAST. Its key feature is that it analyzes source code without running it, without its execution, and is used for application development. The concept design of SAST, input, source code or binary, then it is converted into some intermediate representation. It can be a character, symbol, various graphs, or synthetic tree, or any kind of further custom data, which is subject to analysis. Further, outputs. You get a set of warnings, ranked by their importance and criticality. There are a number of SaaS solutions today for any modern and popular programming language. There are more popular ones, less hyped ones, freeware ones, proprietary ones, but all of them, especially proprietary solutions, share the same thing: PR. If you visit a website which is dedicated to the description of a given tool, you will see there some information. They say that their tool is the most efficient one, the most effective one. And normally this shapes ungrounded expectations, which are actually do not stand the test when faced with reality. We put together a large team working on the banking service. We have budget allocations, we have resources allocated, and they tell us, please introduce a SaaS solution. We don't want to become victims of aggressive advertising. We'd like to assess objectively which of the tools is better. We will take into account lots of specifications and characteristics, but the key one will be the quality of analysis, whether a tool can identify and detect vulnerabilities. How do we characterize the quality? Being able to identify true positive cases, real vulnerabilities, and significantly reduce number of false positives. Let me drill down on this one. For instance, we have implemented a service. We purchased the most expensive, the coolest SaaS solutions. We apply this and we get 1.5K warnings. We feel so sad. Oh, we roll up our sleeves. We started working on these warnings. It turns out that 99% of cases as signaled by SaaS cases are virtually impossible in practice. So false positives, it is also another important indicator. A high number of false positives leads to the impossibility or practicality to use a tool in production. For proper quality of analysis of SaaS solutions, we require independent benchmarks. And at present, there are some of them. I'm sorry, I'm skipping ahead. What would a perfect SaaS benchmark look like to assess the quality of SaaS solutions? It would have two parts. The synthetic component is just a couple thousand simple, but at the same time complex tests which make use of various language capacities of the target language. And we would love this tool to run the existing elements differently so that we can see what's the difference. It should be based on real-life projects. These are previously detected vulnerabilities. This is a way to see how SaaS tools work on actual production code. Synthetic texts are fine, but we'd love it to run on actual code, real-life code. It should run within a certain infrastructure. It must be easy to install and use and run and get some human-readable output data, which leads to certain consequences and conclusions. There is a certain number of benchmarks today. However, the vast majority of them are language-specific, and it is normally designed for C++ languages, or C or C++, because these are one of the most popular languages in such research. Sometimes there is no infrastructure in place, or like Juliet, it is a benchmark, as you know. This is a benchmark that works with all tools, but it's way too simple. Based on this review, we can come to the following conclusion. The existing benchmarks do not cut it for a full-fledged SaaS comparison. It takes a new solution. And we are introducing such a solution today. We tried to make our perfect benchmark closer to the perfect image I showcased a few slides before. It has two components. The synthetic component, which relies on demonstrating the difference between the SaaS performance, and a set of real-life projects which can actually includes various CWEs. There is a version that contains a vulnerability and another version with the vulnerability already fixed, so that we can run a false positive test. This features full-fledged infrastructure which is easy to add to your tool and run some experimental checks. So, how do we shape the synthetic part of it? As mentioned earlier, the formation part is designed to showcase the difference. Why would we see the difference? Because this is a way to identify how they perform in various tests. And second, this is a way to identify which SaaS tools are better fit for which vulnerabilities. Which structures are they unable to process? This would be useful for both the developers of such tools and coders who use such SaaS tools. For instance, we realize that the SaaS tool we're using does not support embedded ifs. It's either we use another tool or we ban embedded ifs. If you use embedded ifs, you will get fired. The synthetic component of the benchmark. There is one way you can roll up your sleeves, sit down, and write several thousands of simple but at the same time complex tasks. But this is very labor-intensive, and it requires competence in various programming languages, and you may probably feel lazy to do so. I said, okay, let's try another way. So we got this idea. What if we take a ready-made testing software, piece of software, and modify it in some way? And probably this modified version of software will highlight some interesting behavior. So I took 3 SAS tools, probably heard about them. I took a chunk of simple code, which includes SQL injection, SQL injection. SParam is attributed data from external query. With this example, all SAS tools could deal with this case pretty simply. But if we add an if, which is always true, so param is always an empty string, so it doesn't impact SQL queries in any way. So 2 out of the 3 tools result in a false positive. That's 180 turn, I thought. And let's take a test piece of software, a test program. Let's modify it somewhat. Let's run the analysis. Now let's then compare the results, the outcome, when dealing with the modified program version. If they are different from the initial ones, probably in this case, we have found a potentially interesting test program, which will be part of the final version of our benchmark. Good. Next up, how to possibly modify software? There are 2 approaches out there. It's either we do this manually, again, this is labor-intensive and you feel lazy, and the second method, why would you need this at all if we have fuzzing? Please raise your hand if you heard about fuzzing. Oh, that's very interesting. But probably not all of us know this anecdote regarding the way it was actually came into existence. It was a dark, rainy night. Professor Barton Miller, who works at the Wisconsin University, was connected to his computer from home via a telephone line connection. With every burst of thunder, the telephone connection would break down due to static. Professor Buttonmiller was surprised by that. The next day he came to the university and he suggested the following to his students. Let's take a set of Unix utilities and let's feed them with data they do not expect. And the results were outstanding. They discovered lots of bugs and even potential vulnerabilities, which might have been used by attackers. To hack into these Unix-based utilities. This is how fuzzing was brought into existence. You know, we all know FL. It took several years to develop mutation fuzzing. Initially, for fuzzing, data would be generated from scratch. Mutation fuzzing is a bit of a more advanced version. So once we're in the software and the data starts mutating, if a function takes it, we generate 42, which goes pretty in deep, but starting to add one or detract one, hoping that this data will bring about certain results. Respectively, you can mutate software in the same way. This is structured representation. It's much more complex than that, but still it's feasible. So the mutants we're getting from the test, the initial software, they need to be systematically in syntax compliant. Because they must be unique, because no one wants the same kind of mutants. And you might think, oh, I'm telling you stories about fuzzing, but how does it work in practice? As mentioned before, I have extensive expertise in the application of mutation fuzzing. Using mutation fuzzing, I was able to find tens of thousands of compiler errors. We posted many of them. Around 10% of all errors, all bugs found in the compiler backend were found by the mutation fuzzing. And they're still trying to support it and use it to test new versions of the compiler. All right. Probably mutation fuzzing is going to work. But the next question is, how are we going to mutate the test software? Let's write a list of regex which will change constants in the software or like entangle strings, replace them, swap them. Probably this will identify some bugs, some divergences, but the efficiency is going to be pretty low. Okay, you say, let's use the structured code representation, the abstract code tree, syntax tree. Let's enrich it with types for static languages. Let's run some cooler mutations. Let's mix these nodes and functions. I might say, yes, it may work, but efficiency is still doubtful. And third, modification using templates. Let's drill down this one. It's much more interesting. Oh. Wrong slide. Okay, templates. Templates are pre-configured structures which are added to a random point in the test software. A key feature is the type-based cells. You can see this in the left-hand side of the slide. Then they are filled with information about variables and expressions available in the scope of where this template goes, where it is inserted. I'm going to showcase some examples further for greater clarity. This is a pretty simple way to ensure a variety of language-based features, uncover, detect specific behavior, and make this a very cool syntax-based benchmark. What does the mutation fuzzing algorithm look like? We have the test software where tools operate in the same way, and a set of templates. Into this test software, we insert a template or a sequence of various random templates. Then we check, we verify whether the resulting mutant is compilable, can be compiled. Then we take a bunch of such mutants and we run a sampling on them, which is composed of our SAS tools. Then we check whether the behavior differs depending on a specific SAS tool on these mutants. If so, this all goes into the result storage. This result storage is accessed by a human, and manually they pick and choose the most interesting test examples. And finally, they are sent to the final version of our benchmark. A case in point is a long-awaited mutation fuzzy case. I'm sorry, the listing is displayed incorrectly a little bit. It used to be fine. We have the initial function that contains the very same SQL injection. We pick a random place, a random template, we fill it with data regarding the expressions and variables taken from the scope, and we see the resulting software on the left-hand side, which may potentially uncover some interesting behavior. Apart from the predefined bodies, the block units on the top right, string equals string, we can make our templates even smarter. And as the body, we can take the already existing pieces of software. In order to insert such a template, we need two spaces, block start, block end. We still need to fill out some type-based cells with information from the scope. Again, we get a test example, which might uncover some interesting behavior. Therefore, using such templates, we can further increase the variability of our benchmark, and thus generating even more test cases, test examples. You may wonder, what am I supposed to do to somehow guarantee the fact that we cover the main language capacities of a given programming language? The answer is this. We need to write templates, for instance, for Java, for the below features. This is for us to be able to state that we support the main language-based capacities of Java, and we can actually test SAS tools with that. The more templates we have per single feature, the better it is. But you might say, that we people, we are lazy. We want to reduce the workload, the labor intensity. But luckily, in 2024, large language models, LLMs, are being applied to each application. But for template generations, LLMs can deal with this pretty easily. Well, it's about syntax, correct syntax.
Сделать с помощью специальных библиотек.
This can be done with specific libraries. You can also extract this from source code using pretty simple algorithm. I'm not going to dwell on this. This slide lists a case of application of a more complex template. It's on the right-hand side. Of course, it is simplified. It implements constructor chains feature of Java. The first constructor calls the second constructor. Below in green, I have highlighted the body of the template, and this is what the resulting code looks like after we have inserted. This is what the resulting code may look like once we have inserted templates. You may think that this is a pretty simple template, but not all SaaS tools were capable to deal with that. I have implemented this. I hit the run button, and then I go to bed. I get back, I go to the resulting files folder. I can't use obscenity, right? I was so much surprised. Overnight, I discovered around 1,000 interesting test software which covers various scenarios of behavior. This is the power of mutation fuzzing, I thought, and I started scraping through them one by one, manually. It turned out to be not so good because the vast majority of these tests turn out to be pretty similar to each other, which is not of interest. Those that are repeated, they contain lots of trash. These are language structures which have no impact on what SAST yields. Not reduce the manual workload. This comes back to laziness. Deduction model and deduplication models. This is good for fuzzing. I highly suggest that you use this. Briefly about reduction. I'm not going to drill down on the algorithm details. There is a test case, a test example which uncovers interesting behavior of SAST analyzers. They operate according to a different principle, but this structure in yellow has no impact on the way SAST tools operate. Therefore, reduction algorithms automatically remove such structures from the software. Thus, we are getting a minimized test case. The deduplication algorithm is a more important algorithm. As I said, the results folder contains 1,000 examples, and we need to categorize them somehow. Thanks to the algorithms that we wrote, all of these examples can be categorized by the dependency type, by the vulnerability type, and they can be sorted from the most interesting ones down to the least interesting ones. The most interesting ones must be the most variable ones. In terms of the template inserted, the behavior they bring about. This is how we can ensure the independent nature and integrity of our benchmark. We start processing cases manually. I would like to point out another thing. For sorting purposes, you can set a scaling ratio for SaaS tools so that the most interesting folder is populated with results where the SaaS tool in question behaves differently, where its behavior differs from that of the others. Good. We did something for Java, but how do you adapt that to other languages? First, we need a test sampling. To get started, we can use ready-made test benchmarks. If it's not available at all, if it's a very rare language, we can use LLMs, large language models, again, to somehow make the conversion. Next, we need to adapt and get our templates again. From what they look like, it follows that they work for virtually most modern programming languages. And they can be transformed with minimum effort. Then we write run scripts, result formation scripts. When it comes to results comparison, this is already implemented on our side. Right, examples. Divergences identified. This is the same SQL injection case, which works perfectly for all the existing tools. We insert a template which is a bit complex, but we use a static class field, we assign param, and we get it again. So we assign to param its value, its own value.
And with this code, 50% of tools were not able to cope with it. The example with false positive. Once again, we have the same test, and in param, we give the empty line. Well, we determined it a little bit in advance, and we apply two simple functions from standard library. And today, one of 4 tools filters such false positive. Well, synthetical part, everything is understandable about that. Let's move to real benchmarks. It's wonderful that we have Chinese workaholics who formed a very big benchmark consisting of 165 projects for Java and have launched 7 popular open source or free versions tools. Out of 165 vulnerabilities, all 7 tools have discovered only 30%. On one side, 30% is good. On the other side, there is a way to move. But how can we get these benchmark and these results? So we have a lot of vulnerability databases. You can go there and collect information about names, versions, discussions, classes vulnerabilities that were discovered in them. But as a rule, there are no links. But thanks to other good guys, there are scripts so that all these names and versions would be converted directly to links, and we build 2 versions of the project with vulnerability and with fixed vulnerability to check false positive. Between these 2 versions, we build div, and then a person comes, expert group from 3 people that conduct cross-validation, which makes conclusion that vulnerability is available and vulnerability is located in this particular place. Then, for these projects, we form serif tagging. I'm not going to speak about it. Serif is a very good and popular format. Many SaaS can do it, and it has a very good color coding in GitHub. This idea was taken for the foundation, and as a result, it's more automated from the approach point of view, and these databases will be extracted and extended by us. Right now, a couple of words about infrastructure. How can we add into our infrastructure interesting SaaS tool? You have to write the run script for a serif conversion if your SaaS tool doesn't know how to do that. And mapping in CV. What is CV mapping? You don't know that. Well, I have two news. Bad news that most of SaaS tools, possibly the one that you're interested in, they have their own format for output of the result. They have the rule of how did it work and the place it did work. But most of them have CV mapping. CV, it's a database of vulnerabilities which is supported and developed by experts in the area of cybersecurity. And this is an attempt of categorize existing vulnerabilities. This database is structured, and on side you see an example how SQL injection can be mapped in CVE class, CWE class, which is called that improper neutralization, which tells you that somehow data is not properly neutralized for the request. So the infrastructure is available. We launch our tools. We parse our serifs, and then we calculate matrices. We calculate number of vulnerabilities that we have discovered. We calculate the number of vulnerabilities that we produced, but they are not vulnerabilities, false positives, and number of vulnerabilities that we have omitted. On the basis of this, we form two numbers, fullness, precision, and on the basis of them, there's an F score as an attempt of balancing the fullness and precision of these tools' operation. That's it. Basically, I've described to you the benchmark. So we have formed experimental version of the benchmark. We've been writing 30 templates for the experimental benchmark for Java. Then we have defined 30 different templates. We took 50 test programs from which 10% are vulnerable, and they have approximately one vulnerability as a SQL injection. Then we take 165 other projects. Then we've been working with it, then we connected it to our infrastructure, and these 160 projects are totally different directions. They contain difficult vulnerabilities, typical ones, and we've launched several popular tools out there. Results. Blue column is the fullness, number of vulnerabilities or percentages of vulnerabilities discovered. Red column, it's precision. How many vulnerabilities that were reported by the tool are truly vulnerabilities. And F score, the green one, is the describing parameter. But in our synthetic benchmark, it wasn't able to do everything with NRCoop. And it has the highest, FSKIP has the highest score because it has less false positives. In real projects, not everything is as good. The best one was QL, which found 14% of vulnerabilities, but everything is a little bit better from the point of view of precision.
На слайде представлено распределение по...
On this slide, you can see distribution through discovered vulnerability classes in real projects. And as you can see here, the best one, vulnerabilities are discovered by the class 707 that we've been looking at, or 664. The wrong work with resources. You have initialized them properly, you have not released something, and because of it, we have some vulnerability. What I wanted to bring to your attention, that even on this graph, you can see that different tools work better with different types of vulnerabilities. There's not one tool that wins everybody. Different tools work differently. Okay, let's speak about analysis a little bit. Data analysis. Synthetic benchmark has to be extended. We have to write more templates, generate more clever code so that we find more deviations in work of different SaaS tools. However, the benchmark which is available has discovered a lot of false positives. In those tools that we've been researching. In other words, in our benchmark, they give much more false positives than in the region of Wasm. Well, why haven't we discovered, not we, them, why haven't they discovered 70% of vulnerabilities in real projects? First of all,
Для некоторых уязвимостей не было написано
for some vulnerabilities, they have not defined rules. Well, minority, 4 or 5%. About 70% are insufficient quality analysis of the source code. It's the area for improvement of the analysis quality for SaaS tools. And number 3, it's all the rest. And down here, we are looking in theoretical SaaS limitations and vulnerabilities which are very difficult to find by it. And with the help of benchmark, we can reply to a big number of questions. What SaaS doesn't work for me? Which combination of tools can be used in my project as the best one? Which rules should be disconnected so I wouldn't have 1,500 false positives of this tool, knowing that another tool finds much better these type of vulnerabilities. And performance analysis will give you information about in which cycle of development you have to apply different SaaS solutions. For example, Simpra is very fast one. It can just be launched every day, compared to CodeQL, which can work for a long time with big projects. What are the plans? First of all, we are going to extend the synthetic part of the benchmark and the collection of templates, methodologies, possibly somehow will be improved. Also, we will receive realization in forming of a real part of the benchmark to have less manual work. Then we'll complete benchmark for Java, then we'll make for Python, Sharp, Go, big experimental research, and then we'll publish possible results.
Точнее, экспериментальный бенчмарк, про который я говорил, он...
Experimental benchmark I was speaking about was already published. You can go to repository, and they have all the readmissions, all the scripts, and even contacts in README of the organization. If you want to write me a couple of nice or not really nice words, well, everything is absolutely free.
Все, на этом все.
Well, that's the end of my presentation. If you have a desire to evaluate my presentation, scan the QR code and you can write me. Thank you very much, Daniil. And right now we have the Q&A session. We'll read the questions from the board. Okay, I'll stand from the other side. Wasp Zap. Is it SAST? Wasp Zap.
Это немножко не в скопе доклада.
It's not in the scope of presentation. It's a little bit further. Tomorrow there will be a workshop about SAST, and you can ask these questions. Can you do attacks against IP infrastructure to SAST analyzers through the rules with exploits?
Возможно, да, но
possibly yes, but modern SaaS tools, especially proprietary ones, have closed rules. That's why it's complicated. What is worst for SaaS? False positive or false negative?
Наверное, нужно все-таки баланс.
Well, we need a balance.
Максимальный показатель.
We want to show true positive as maximum as possible to find real vulnerabilities and minimization of false positives. While most all domestic SaaS analyzers for writing custom rules offer only regular expressions. Possibly because they don't have a solo type of analysis. Or these are the rules that will be written and it's difficult to adopt them and it's difficult to write them. Which chair should be selected? True positive or increase the true positives? Well, the balance is the most important. You have to work in both directions like Jean-Claude Van Damme on these two tracks. Try to move into the happy future. Is it possible to use rules written by artificial intelligence? Speaking about templates, rules. Well, this is also not in the scope of my presentation. This is related to the work of SAST Analyzer. We should do separate experiments and research from the point of view of how the LLM or another AI can write rules for the SAST. Maybe it's not going to work, but we have not conducted such experiments because we're not developing SAST. We are comparing them. How can one fix false positives on slide 22 with SQL?
Как повесить false positive?
How can we fix false positives?
О, долго. Я просто не помню, что там. Но есть возможность еще раз презентацию посмотреть.
There's a possibility to watch the presentation once again. Slide 22.
Никак.
No way.
Что делать с мультиязыковыми проектами, если нет
What can be done with multi-language projects if there is no SaaS tool which covers all the languages?
Я уже говорил по результатам тех
I've been
экспериментов.
already speaking about the results of those experiments.
Лучше использовать всё-таки
Even for one language,
и
it's better to use the combination.
тоже нужно учитывать их перформанс, но для каждого
You can take into consideration their performance, but for every module, for every language,
даже
one
комбинация.
should take a tool or even a combination of those, which is going to work much better for different type of vulnerabilities.
дубликацию?
How deduplication should be conducted?
Пошел обратно. Я заготовил слайд, просто это достаточно интересно.
Yes, I have prepared the site, and it's a very interesting question.
Думал, что мне его зададут.
I thought that you will ask me, and I have prepared
Я подготовил заранее слайд. Это достаточно интересно. И редукция.
the slide. It's a very interesting deduction, deduplication, and have assumed, well, I didn't want to press too much on you,
Вот.
but it's very interesting. Okay.
Мы знаем, какой
First of all,
содержался в исходном тестовом
we didn't know which type of vulnerability was in the initial test example. So,
категоризации по уязвимостям. Тут, в принципе,
speaking about categorization of vulnerabilities, it's understandable.
То есть явный дубликат.
Then we filter obvious duplicates. When, for the same test example, we have applied similar sequence of mutations, same templates have been applied, and we received same deviations in the work of the SaaS tool.
Отфильтровали там 50%,
We filter it
даже 7%.
by 50%, even 70%. Then, for every test program, we fix the sequence of mutations. We look which templates were introduced.
Эта программа, этот мутант получил
So that this mutant, this program would happen.
информацию для всех примеров.
Then we take all this information for all these examples and we apply this much patch.
Алгоритм, который вычисляет.
This is an algorithm which calculates,
Используем для вычисления меры сходства.
and we use it to calculate the level of
Самой дальней точки.
similarity between text. And then the algorithm of remote point in the left part of our categorized list.
Те
We send those test programs which have these sequences of forming these test programs, and they are very different.
Понятно объяснил.
I hope I described it in a more understanding way.
Учитывается вот как раз вот эти масштабирования.
Then also we have to take into consideration the scaling coefficients of the tools in this assessment.
Как SAST-инструменты научить
How
работать с
SaaS
языками
tools can be
стандартных
learning to work with non-standard TCL
Это уже
languages.
тоже немножко про создание SaaS-инструментов.
This is also about development of SaaS tools.
Адаптацию именно подхода для языков с
About adoption of the approach for the languages with non-standard grammar.
для всех языков там есть.
This can be done for all the languages. For all the languages, you can build IST, you can write templates and somehow mutate them. But how to build SaaS, it's not in the scope of this presentation.
исходники. Какой бенчмарк, если не
Will we have source codes? What is the benchmark? If not self-written, which one of them you will recommend?
Вот.
Source code is available.
Ссылка, либо QR-код.
URL or QR code.
Кто спрашивал, может сфотографировать дополнительно. Можно вообще, в принципе, в организации
You can take a picture of it,
несколько репозиториев. Все достаточно.
or you can go to our organization. There are several repositories. It's very interesting and well described.
Марка.
About the benchmark,
Такого
Well,
прям вот, чтобы есть различные там бенчмарки, которые формируются из баз
there are different benchmarks which are formed from vulnerability database. NIST benchmark, Juliet benchmark, which is a very simple benchmark for
так, чтобы
a lot of programming languages. So that in order to have some ultimate benchmark, which I would recommend, no, there is no such
табличку
thing.
Заново вспомнить мою, либо
Either you can remember my
посмотреть Awesome list
spreadsheet that I was showing, or look at Lawson lists with different benchmarks, and it all depends on what do you really want to test.
Обычно есть результаты.
Benchmarks usually have results. How, in case with mutants, can you solve problem with false negatives?
Хороший вопрос. Заранее
Well,
говорю,
a
это
good
хороший
question.
вопрос.
This is the best question
У
I
нас
would like to say right now.
финальная версия бенчмарка формируется.
The final version of benchmark is formed by a human being. We have an expert group which does the cross-validation, and they say,
Является ли в этом
and they come to the conclusion whether this mutant has vulnerability or not, and therefore they form the tagging. It is done by expert group. However,
тоже можно немножко упростить процесс. Правда, мы еще
one can also simplify a process. We have not been doing that. If you apply dusts
сгенерить
to
exploit,
try to generate exploits for the mutants, and if exploit has been generated, this can be done for Avast.
сказать, что да,
Then we can say,
мутанте содержится
yes, in this mutant,
содержится
we do have error vulnerability. If not, then still one will need manual processing. In other words, expert group.
Так как
Tools
правила
ништяк.
из коробки работают плохо.
No rules, but rules out of the box do not work very well. Did you write rules for SAM prep for your cases?
Мы там короче, в синтетическом
Well,
бенчмарке там, в принципе,
In a synthetic benchmark,
достаточно все просто.
only SQL injection, everything's very simple, and everybody.
На
There's big number of rules.
уязвимостей.
This is that type of vulnerability.
Ну, мы не заинтересованы в том, чтобы
As for CVE benchmarks, we're not interested that SaaS tool would become a winning one. We're just checking them in real conditions.
какие-то правила для SimGrep, чтобы он внезапно
Why do we have to write any rules for SimRed to make it win?
смотрим, как
We're absolutely independent. We're just looking how the tools are working.
Показана
On the
схема,
slide 32,
стадия
we could see the scheme which has the stage of compilation after in-building the templates.
Как происходит
It's a syntactic test. How the semantic test happens for the code acquired? Through the compiler, same way.
код компилирующийся, то он синтаксически
If the code is compiled, then semantically and statistically it's correct. How it behaves in the right time,
потому что у нас SAS.
it's not as important because we have
Там
SAST.
же дальше человек будет валидировать результаты.
And then person will validate the result.
рационально ли использовать SAS для небольших проектов?
Is it rational to use SAST for small projects?
Рационально использовать для всего.
SAST? Yes, it's rational to be used for anything.
В библиотеках находится
Even in smallest libraries, they have vulnerabilities which can be exploited by anybody.
Проводился ли анализ сложности реальной
Did you conduct analysis of the complexity of exploitation of 70% non-discovered vulnerabilities? Possibly this can be covered by other classes of tools.
Это тоже, опять же, очень трудоемкий
Well, it's the same, a very labor-intensive process,
На
and the minimal research,
минимальные исследования этого производились.
minimal research
Из тех,
have been conducted.
те 70% найденных уязвимостей.
So those 70% of discovered vulnerabilities, and I did have slides. Some people just have problem with the theoretical SAST limitation, and some of them cannot be discovered completely. Some of them don't have rules, and some of them
Возможно, там
are
забрала
being exploited. Yes,
ошибка, но
maybe there is some kind of an error out there, but vast majority of results are correct.
Каждый инструмент
So it happens that every tool interprets results his own way. Maybe it's easier to model tests on the basis of developed software.
интерпретирует по-своему, но
They interpret in their own way,
и мы
but
сравниваем
there are certain mappings, and we compare CV classes.
объединяет под собой
CV class unites
непосредственных
big number of direct vulnerabilities, real one, and there we tried to change these deviations for tools. We compare CV classes.
А что внутри папки самое интересное срабатывает?
And what is the most interesting inside of this folder? The same 1,000 of warnings, but they all divided by CV. So these 1,000 warnings have to be manually divided, but they are divided by categories. The most interesting warnings, they are maximally different and they lead us to maximally various results. We manually separate several dozens of first ones, and then we have real duplicates of those that were processed manually. In other words, you can see thousands examples we're not looking at. We just take several dozens in the beginning, and then we see real trash that we're not looking in. How the benchmark results influence developers of SAST analyzers? Do they have any reaction to this? Well, we started working just recently.
Только недавно мы заopen-sourcили наши бенчмарки.
Just recently we have open-sourced our benchmarks. There were no publications. However, it's going to be interesting. But generally speaking, I've been making a URL to an article.
Приводил ссылочку на статью, вот это.
I've made a link to an article, yeah, this one.
Большое исследование.
These guys have conducted a big research for Java, and it was noted by authors and Wasm and many other tools. So they perceived it very positively. Well, we have not published anything publicly. All this will happen in the future. This is work in progress, as I've told you.
Спасибо большое, Елена.